Okay, so I'll be solving problem 9, palindrome number. The problem states, given an integer x, return true if x is a palindrome and false otherwise. An integer is a palindrome when it reads the same from left to right and from right to left. So it's the same forward and backward. They give us an example here, x equals 121. When you read it from left to right, it's 121, and when you read it from right to left, it's also 121. Now, an example of an integer that is a palindrome, they give us negative 121, because when you read it from right to left, it's 121 and then the negative sign, which is not the same as the original x, which is negative 121. Another example would be 1212, as when you read it from right to left, it's 2121. And they're both different values. Now, how I would approach solving this, I'll just reverse the number and compare it with the original number. And if they're the same, they're a palindrome. And if they're not, then they are not palindromes. The integer x is just not a palindrome. Now, first, what I would do is I'll create a copy of x, and I'll create pal, which is the reverse number I'll be building. I'll set up my while loop, and I'll set copy of x greater than 0. So this loop will keep on looping unless copy of 0 is less than or equal to 0. And to build the reverse number, what I would do is I'll set pal equal to the last digit of copy of x, which you can get using copy of x mod 10. And yeah, so like when you mod 10 121, you get 1. And because I'm like using a while loop and I want to keep on building, I want to like get 2 and then get this 1 over here. What I would do is move, once I get this value of 1, I want to move that to a tens place and put 2 as the ones place, if that makes sense, since I'm reversing the number. And how I would do that would be multiplying pal by 10 and then adding the new value. So before I like go into further explanation, after doing that, you do want to do integer division by 10 to get rid of the value you just used in copy of x. So let's like run through 121 over here. So 121, that's greater than 0. Pal equals to 0 at this point, so it's just 0 plus 1, and copy of x just becomes 12. And then 12 is greater than 0. So that would just be 10 plus 2, which is just 12. So that's what pal is right now. And copy of x becomes, copy of x becomes 1. And 1 is greater than 0, and that just builds pal. So pal is now 121. So this all checks out. And now you just return whether pal is equals to x. And if they're equal to each other, then the integer x is a palindrome. However, there is an alternative approach to this problem that is much faster, in my opinion. So I wrote out all of the code. I just want to save everyone time. Low-key wanted to save some time explaining it too, or like writing code while explaining. But when you're given like 1, 2, 2, 1, 1, 2, 2, yeah, kind of notice that they're mirrors of each other. Like 2, 2 is over here, 1, 1 is over here. They're mirrors of each other. Same with here. Like if you split, I mean, you can't split like 1, 2, 1 in half, but if you split it, it's like, you kind of get what I'm saying. But basically, instead of building the whole entire reverse number, you're only building half of it. and I can just run through the code. So if x is less than 0, so we all know that negative numbers are not palindromes, so we just automatically return false. And we also know that any number mod 10 equaling to 0 is automatically a number like 10, 30, 50, 100. Those are just not palindromes, so we can return false for those too. And I think like 10 kind of gets in the way of this as well, but we automatically know that they're not palindromes, so we can just return false right off the bat without having to reverse the number. But for the rest of the numbers, again, we initialize pow again equal to 0, and while x is greater than pow, so we want to like only solve for half of the reverse number, and we use the same building technique for a reverse number, except this time the while loop condition is just x greater than pow and not x greater than 0. And yeah, the return statement is what's important. So let's say we have 1, 1, 2, 2, 1, and by now x would just be equal to 12, right? And when you go from right to left, what we have for pow is 12, and what we have for x is 12, and thus, because they are the same, they're mirrors of each other, they must be a palindrome. Now let's take a look at this condition. Why this condition? So this condition accounts for palindromes that have an odd number of digits. So when we're like building half the number, again, like you can't split 2 in half. I talked about this earlier. And instead we do build 2 digits of 121 in reverse order, and we get 12, and what's remaining in x is 1. And this is like, obviously pow does not equal x in this scenario, so what do? We can get rid of the odd number. The odd number is its own mirror, if that makes sense, and we get rid of that by integer dividing by 10. And when you integer divide by 10, what do you get left? 1. And what is x? 1. So 1 is equal to 1. And that is why this works. We just get rid of the middle number. That doesn't really matter. And we compare the rest of the numbers of pow with x. And yeah, that should work. Oh shit. Yo, I found the error. So basically, like, that shit was also making 0 equal to 0 equal to false. Like 0 is a palindrome, and by having only this, it was returning false as well. So you also gotta state that like it can't be equal to 0. Like, yeah, x can't be equal to 0 in this if statement. So yeah, that works. Everything is good.